So let's see. So what's our data? Okay. First part of the problem, we're just taking the data. I converted it for you to kilometers because I think in the end it talks about 5 kilometers for the last part. So you want to make sure your units are the same. So if we click on this website, it lets you type in your X and Y column. So at 0, response is 0.55. And then at 1 here, I'll just type them all in. 1, 2, 3, 4, 5. And then this is 0.65, 0.75, 0.775, 0.6, and 0.55. And then if we click here, we want to increase the degree because I think it says in the instructions we want a degree 4 polynomial because you got 5 variables. Then that's if you it's not 5 variables. Sorry, if you have 5 observations, then you could solve for 5 different constants in that pretty big system of equations, right? So increased degree, now it's to the third power. There's to the fourth power. 1, 2, 3, 4, 5. So that's the highest degree we can have. We'll click calculate. And so it creates a polynomial that best fits this data. And so that's the polynomial you're going to want for part 1. Now look, I'm not giving away the answers. Just so watch out for that. This video is on really similar but slightly different data. Okay, so that's the polynomial we need for part 1. We're going to need to type that in just a bit because we're learning this week that we can find the length of a curve by using calculus, by using integration. Okay, so it starts down here, the runner goes up at big elevation, and then our model guesses that it drops below that elevation and comes back to the starting elevation of 0.55 kilometers above sea level. The model is never going to perfectly fit reality. I guess that's something important to keep in mind. So state the integral. What I'd want to do for my part is I'd want to use, I don't want to give too much away here, but you'll want to use the formula that that our textbook derived this week to state the integral that we're going to type in an online calculator. Okay, so you'll want to go back, and I'm sure you're familiar with it from what you've done for homework this week, but we want to state the formula for the length of a curve, but instead of using the derivative of fx in that formula, you actually can find the derivative of fx yourself, right? Because it's just a polynomial. So for the second part, you're stating the formula for the length of the curve from 0 to 5 for this arc length. Okay. Let's see, part 3. Okay, so this is just typing it in a calculator. So if you click this, there's lots of integral calculators. The most important thing in mathematics in our modern world is knowing what to type in these calculators. And then I guess knowing what happens behind the scenes is important in case the calculator fails us. But so it's asking for the arc length. So you should be able to just type in your polynomial here. So whatever you got for a polynomial in part 1. I'm just making up numbers. Okay, type in your polynomial. You want to do it from 0 to 5. I stopped typing in there because I trust that you're able to type it in. Remember the caret key, that's found by doing shift and pressing the 6 key. So there's our integral. Oh, wait a second. What is this? I gave you an arc length calculator. Okay, so if you don't want to type in exactly what you got in part 2 in here, because the calculator I've given you is already an arc length calculator. It's taking your polynomial and it's already doing the calculus part by plugging it into the other thing you could do is you could just Google search an integral calculator and type in your integral for part 2. I'm okay with whatever you want to do, but it's a tough integral by hand, so I want you to use technology for that. And then so for part 4, the final part says it's 5 kilometers as the crow flies, but how many horizontal meters were added by the hills? You know, if you run a hilly course, it's 5,000 meters by your GPS. That's not accounting for the amount of meters you've gone up and the amount of meters you've gone down, right? Because those are diagonal, so they were adding a little bit of distance that way. So using our model, how many horizontal meters were added? All you have to do is take your answer in part 3 and subtract it from 5,000, or subtract it by 5,000, I should say. And that's it. I want to make this video because the first applied problem is just as straightforward as that. There's not a lot of tedious calculations. Want to make sure you knew about using that free online technology. Don't try to do this by hand, okay?